Hello and welcome back to another video here on the Ludwig Fusel channel. In today's video we're gonna continue on writing our C++ code for 3D modeling. In the end it shall be Lua, but currently it's C++. Now as you can see I have reworked a few things. Now the info warn and error function is now properly bound to Lua so that we can have multiple log levels, but that's not really what we are going into. This is just some stuff that I randomly have implemented in that video series while you were kind of like away. But yeah, it was like faster to implement than now talking about it. Now let's continue on with ChatGPT and ask it how MTL files work, or MDL, these model files. How do the MDL material MTL, how do the MTL files that work in combination with OBJ files work? So let's ask ChatGPT how they work, because I want to add material so that we have full implementation of the OBJ features, and then we know how we're going to continue on. Material name, ambient color, diffuse color, specular cover, specular exponent, transparency, optical density, illumination model. Okay. Map KD. So this actually is already a good information. Now in general we can define as thing colors and we can define textures. Now one question that I have, does map prefix work with all color informations? So what I mean is stuff, does it work for KA, KD, KS, NS, probably also D. Let's see. I just query a bit of information to ChatGPT so that we are getting some insights for various material properties. However, not all properties use the... Okay, so common... No, okay. Specifies a texture map. Specifies for ambient color. Can you give me all keywords like map KD, etc. that work in the MTL files, please? Please do a short explanation for each. Alright. I want to just have an insight on all of the keywords so that I know how to structure my code. Ambient color. Hopefully it's now then also going for the KA. But we have a bit of an insight on how it works. So let's try and translate these insights into code. So we have the OBJ file. So now I want to have the MTL file. Let's implement now the MTL file. And I want to do it a bit similar to how it has been done here. Luma 3D. Let's hashtag include DirectX math as well. And let's start by saying using MTL color equals to DirectX XM float 4, because the color always has 4 components. I'm not sure, was ChatGPT giving me insights about the colors with 4 components? It was not. Do the colors always use 3 channels? Let's ask it about that. If colors are typically 3 channels corresponding to... Yeah, it kind of makes sense. So then let's also use the vector 3, because I think vector is what we use, XM float. X and float, yeah. I'm a bit of an idiot sometimes. Okay, so let's start with the MTL file. So, let's struct. What does an MTL file contain? An MTL file contains multiple materials. MTL material. This is kind of like the root. We're gonna have multiple materials that are stored in a list. So we have the MTL file, which is collection of materials, and then we have the materials defines a unique material. So the material itself is defined by a material name, so an std string material name. So this is kind of like the label of the material that's required for referencing the materials. Now here we have an std list of MTL materials called materials. I'm not sure, is the file format also starting with a comment? Does the file MTL also starts with a comment like the obj files? Let's see. Let's see what ChatGPT is saying to this question. Can also start. Okay, so we also have these comments that we can do. So in the obj file, there was the starting comment. I want to have the same thing here as well. And now what I want to have then down here is I want to have kind of like a list of materials defined by that file. Okay. With something like that. So now we have the material, now we have the material name. Now, additionally to this name, we are requiring the parameters that the material can have. Now the question is, how do I want to add these material parameters? Do I always add all parameters? Let's ask ChatGPT. Is there a minimal set of properties that material needs to define? So is there a like minimum? Isn't a strict minimum set? Yeah, of course, it's always gonna have a property. Okay, so what I then want to do is I kind of like wanna overlay my materials. So what I want to do is have a struct imtl property, and this is gonna have a virtual imtl property default destructor. The virtual void out function, so it's gonna have a function so that the material can be outputted, but I don't really love to use structs. And I think we can do it differently. We can do a struct mtl property. So we can have a property, and every property has an ID, identifier, and this is kind of like now the identifier that we are using in empty. It's the key in the MTM file. Key of the MTL property. So I kind of like want to store these as a key value list, and then what we're gonna have is a union in here, because we need to have some way of distinguishing the different materials. And what we additionally need to that union, we need a way to define the way it's used. So I want to have an enum class MTL property type, and I want to define a property type. So type of property, and this is a material property itself. Now we can define the certain property types. What we could actually also do, instead of storing the identifier as a string, let's completely store the property type in here so that we can then kind of like use it a bit more easily. Now basically what we have is we have this KAKD. Come on, Windows, you are having fancy features nowadays. So let's maybe do it like this so that we have a bit of a better way of seeing it. And then let's quickly start just writing this down. KD, KS, NS, oops. It's not what I wanted to write down. KAKD, KS, NS, D is the transparency, with D being the inverse of TR, transparency of the material. Okay, yeah, let's use TR. Then we have NI, Elum, what the hell ever this is, why it's like kind of like out of the usual map D, map KA, map KS. Map NS, map bump, map D, disp, raffle. So these are kind of like the certain types that we can have. Type. So then we can encode the type in here. We can say type of the property, and then we could add like some Doxygen description to all of these, but I think I shall do this myself. This is not what we shall do in a YouTube video. Probably this is a bad idea to do it at all in the video, because it's gonna harden the way that we code in quite a way, because then I can copy paste later into multi-line editing. But yeah, so let's take a look at the certain parameters that we have. It's the ambient color of the material. So we have an MTL color as a possible value, which I'm gonna say name is color. Ambient color, diffuse color, specular comma, specular exponent. Now the specular exponent is, as far as I know, specular exponent, it should just be a float, I think. Specular exponent is called Phong exponent. Yeah. Shininess between 0 and infinity. Okay. Yeah, I don't know, but it's probably going to be a float value. So let's name it float, and instead of color, let's name it float itself, or color value and float value, so that I have the value suffixed. Yeah, so we have either color value or float value. It's the transperial, how transparent the material is. Okay, so let's prepare. Please give me the data types of TR, NS, NI, Elum. So let's ask for the data types here. These maps are simple. The maps are always just going to be a path. Come on. Okay. So let's ask about the data types. Floating point number, integer. Illumination model is an int. So int value is something that we need as well. And we also need the string value that I want to just keep outside here, because I think an SVD string should never be inside of a union to begin with. So now we have the various ways of displaying the data, and now we can actually take this property and store them in here. So we're gonna have a list of properties, and this is gonna be called properties like this. And then we're gonna name them material properties. And now the only thing that we need to really care about is that we are always specifying the right kind of like type, and kind of like interpreting this right. Alright, so what we now need to do is we need to find a way of enumerating these. So first of all, the MTL property type, let's write an operator for that one. So I think we do not have OStream yet. OStream here, and then what I want to make is a std OStream reference operator shift of a std OStream reference out and a MTL property type, so it's like copied. Can I quickly collapse this somehow? Doc. Of course. Of course, it does never work how you intend stuff to work. Okay, so let's do it differently. Let's do it Lua property type. Now we have that function in here. We just need to create a matching source file. We can start with the implementation, so switch on the type, then we return out again. Now if we are switching on the type, we need to have all of these information available. And this now comes the power of multi-line editing. So what I'm gonna do is I'm gonna do case Lua MDL 3D MTL property type. Like this, KA. Then we're jumping here. Then we are going down. And then we're gonna say out, shift, control paste, semicolon, break. And there you can see, easily converted. Alright, so now we have a way of displaying these. Now we just need to have a way of displaying the properties themselves. So std OStream reference operator shift std OStream reference out Lua MDL 3D Lua MDL 3D MTL property reference. This can now be a const reference property, so that we have a property here. Alright, and then we can implement that property function. And now what I want to do is I want to have a certain way of outputting these. So actually what I am going to have in here is I am going to have a MTL property function for each of these. So I'm going to have a void output MTL property color, and then I'm gonna have a property in here and a std OStream reference out, and then it will, no matter of what type it is, spill out a color. We're gonna have this one for all of these, so we're gonna have color float int and string. Now we're gonna create these implementations. They of course shall go in here, and let's do it like this. Let's do it like that. Let's do it here. And then what I am basically doing is, no matter what, I am gonna output the property. How did I name it? I never know how should like write property, because I don't know. Seems property seems to be some kind of keyword nowadays in C++, which I don't really understand why it should be, but yeah. Property dot type. So first we're gonna output the type, which should work with no problems. And then I'm gonna output the color value, and I'm gonna output a end line. Now you can see this currently does not work, but you should not be too concerned about this. This should then also work for the float. For the float you can see it already does work. Int should also work with no problems. And then string should also work without problems. Now the color value does not work because we don't know how to output color. So std stream reference operator shift std stream reference out, and then we're gonna have a mtl color in here. And let's make it as a const reference as well, because the color is kind of like some larger amount of data. It's not non-trivial struct, or it is kind of trivial, but yeah, it's always a bit hard to decide what to do in these cases. Alright, so now basically we're gonna borrow our code from here, from the obj. Basically this is what we want. This is what we want to paste in here. So we are missing IO manip here, and then the only thing that we need to change is like color, and then we can also index x, y, and color.z. Alright, so now we have the way of outputting the color, which should fix this up here. Yes, it does. And in theory, this should now be good. And now we can go on to the property and implement the way it's drawn here. So basically what I want to do is I want to steal myself this. Okay, we can... is it easier to steal it? I don't know if it's easier to steal the switch. Yeah, let's steal the switch. We need to reconsider. We still need to reconsider everything. So, yeah. So let's get started by going in here. So instead of switching the type, we have the property, and I want to have the property type. Now, dependent on the type, I want to do simple stuff. So first of all, KA, KD, and KS are, I think, all color values. KA, KD, KS. Ambient color, diffuse color, specular color. So these are all colors. So instead of outputting them here, I'm basically going to say the color file output mtl property color, output color and property. So now basically I'm going to forward these. Now ns, tr and ni, as we know, are float values. DLD here, output float, so out and property. Now we have a float outputted. This one is a an integer. Output mtl property int, like this. And then we have maps, and all the maps I think should be in general maps. So all maps. And maps are always going to contain a file, as far as I know. Now, texture maps always specify files, question mark, do I need additional infos? No way, ChatGPT doesn't like my enter today. Additional options. Scaling, offset, retortion, tilting, and blending. Okay. Please explain all of the modifiers for maps. Come on. So we have actually a bit more of them. So, okay. So let's adapt this. Instead of string value, I'm going to call this one like map path, and then we also need to have a way of having map modifiers. So mtl property, okay, But we can for now make it a bit easier. Instead of this being string, it's going to be property map. So in this function, we really not concerned about that. Inside of the map function, we are concerned. You can see I'm just forwarding, and this one shall no longer work. So now we would have map, and everything would have been easy. So map path. However, the map path is the last thing. Clamp. Okay. Let's see. Offset modifiers for shifting the textures. You'll be how much to offset the texture in each direction. This starting point. Scale modifier for resizing the texture. Control. So turbulence. Oh. Clamp. Wow, there's a lot of that. Actually, more than what. I think I don't want to use them for now. How often are these used? Let's for now forget about these. Let's for now just be fine with that. Okay. So I now know how to export an MTL property. So now we need to continue on. The MTL material is the next thing that we need to output, and then we need the MTL file. So let's continue on with these. Let's copy them. MTL material and MTL file and material here. Let's continue on implementing these. Now, in general, what I want to do here is, first of all, for the material, we need to output a name. So, new MT, was it new MT? How was the syntax? New MTL, okay. So new MTL means new material, and then I have my material name, and then I end it with a new line, and then I will go for my const auto reference property in the materials properties. And then I'm basically outputting every property with a end line. I think the end line was already printed up in these ones. Okay, yeah, they are already printed here, and it doesn't really matter. So let's just output all of these here. That's okay. And then let's return out to complete the way of outputting a material. Now let's implement this for a file. So first of all, the comment, this works similar to what we have done here. So basically this one goes in here as well. Now you can see SS string stream is not working. S stream here should make this one work. SS line file.comment. Yeah, this works exactly copy and paste like it should be. Alright, so for const auto material in file materials, basically what I want to say is out the material, and that's everything that we need. We can return our out. All right, so you know what happens next. So next what happens is I am going to copy and paste this one, and I'm going to tell please now generate me 6 materials of a metallic cube only using colors. The metallic cube only using colors. Every of these materials shall have a different color. Write me some C++ code to populate the MTL file with the new materials. This is my header defining the structs to be filled. Alright, so this is what we got, and let's see if ChatGPT can again provide me some nice information. Okay. I am really intrigued to see how it works. Red. Okay, it's doing armor. These are actually not very interesting colors. Now you're mixing these probably. Of course you do. Okay, 1, 2, 3, 4, 5, 6. Yeah, makes kind of sense that it goes for that road. Okay, and then it just goes through these. Material names. KD. Specular color. Aha, see, very nice. Specular exponent. Yeah, it's funny. It's funny. It's actually quite straightforward, and I could have come up with this on my own, but I would needed to consider finding the right color values for the specular and for the exponent. So yeah, ChatGPT is giving us quite a big advantage on stuff like this. So now to our good old friend Create Cubes, which was already authored by ChatGPT. Welcome the Create Metallic Materials. And now what I want to have is the MTL file in here. All right, and then Lua. Oof, that's not what I want to have. I want to have it in here, and let's hope that this. It seems quite well from the code. I don't think there should be any problems. Okay, and now we have it. Now we just need to do it like this. So you can see currently this was done for the object, and what I now want to do is I want to have the Lua MTL file, and then I want to say create metallic materials to the MTL file, and then I'm taking this piece of code and this is f out obj, and this is f out MTL file, and then this is going to be called cube MTL, and it's going to be outputted. Now this is going to generate the files, but it's not going to link them. We need to implement the linking into the obj file. Now in the obj in general, we should have some information way up here. No, this was still like with the Lua stuff. I haven't really. Okay. OBJ. The OBJ file format. This one should be the one that I need. And there should be some way of referencing the material. So we have the use MTL. Okay, so maybe let's ask ChatGPT now. It's easier. How to now use the generated materials in this OBJ file. So I just want to split the cube.obj, and I want to allow ChatGPT to add the materials. Let's see if it directly knows. Okay, so MTL lib is already the right one, so it's probably defined on a per file base, I think. And then it like continues on. So let's start with that already. So I have the objects, and let's use the MTL file. So MTL file name, which is by default empty. Reference to the MTL file name. Well, let's just do it like this. And then inside of the groups, we are using the MTLs. So we have the object, and in the group, we are using the material. And I think I'm going to ask him if is the use MTL in theory also possible to use in... Is the use material in theory also possible to use globally on the object, because I suspect that this is the case actually. because it's kind of like a state machine. You always give, like the Blender while interpreting the OBJ has a kind of like state machine that iterates kind of like over these sequences that come, and they kind of like with the commands you alter the state, and depending on which state you are in, the data's processed in a different way. This is kind of like how it works in the end. mtl-lib, use mtl. This is what I want to do. So the mtl file name is now inside here, and then what I want to have is at the object is the object name, and I want to have an std string material name in here. So name of material for the object. And then inside the group, I also have an std string material name. This is the name of the material for the group, for the groups, like this. And now we just need to implement this. Can I actually go directly in here? Is it now directly in here? No, it's for the obj file. But that's not a problem. We are now in the file and we're iterating over the objects, and now we just need the material. So if file mtl file name empty, so if it is not empty, what I want to do is I want to output mtl-lib. And then I want to provide the file mtl file name as the endl. So now we have the material in here. Now we just need to link against these. See obj file, mtl file name. This is what I now need to do manually. mtl file name is going to be cube.mtl. So now this is linked. Yeah, there's a reference that's missing. That is why it's highlighting that here, but I didn't want it to go in here. So mtl-lib is in here. So we have the file defined. Now up here we have the object and the object name after that. So if object material name empty, so if we have a material name on the object, we can say use mtl. And then we say object material name end line. It's similar like that. And basically this is what we exactly need to copy to the group. Then we're going to have the group name. And then the same goes for here, but without like object, we want to put it to group. Okay, so now we have the materials in here. Now we only need to implement this in our generator. So you can see that we have the material names in here. Actually, what I want to take is I want to steal the material names. I'm going to put them up here, and I'm going to resolve something that ChatGPT does, which is super stupid. Just make these constant pointers. We don't need to modify these. This should now allow them to work here. Okay, material name is recognized. Let's rename this to G underscore material name so that I can see that this is like a global. And these material names are seen for the sides of the cube. So you can see at some point we are making some faces in here, and I think this is now no longer working because of the missing material name, which I can quickly just select like this, and now we have material names in here. 1, 2, 3, 4, 5. Now this generator should again work, hopefully, because it's the group. I'm not sure because we have the cube. Where's the cube created? The cube is, I think, yeah, it's created like this. So this should work, and now we should have a textured, or not a textured, but some object with a material. This could be one or more multiple defined symbols. This is something that I feared because this using is it is kind of like what we should rather do is make it like this and make it a public. This seems super useless, but I think this should fix the issue. No, it does not fix. Can't convert from float to... Alright, so what we need to do is we need to factor these out. So you can see that we are using the color output stream. This is something that we are not allowed to do. We need to do it differently. This one, I think. We need to do it differently. I'm gonna call the header to them. Let's call it directx mass stream.h. DirectX master stream.h. If I go into my obj file, we should already have have vectors for these, for output for these. And basically what I want to do is I want to include DirectX math. I want to include ostream and IO manip for IO manipulation. And I want to insert them in here. However, I want to have them as a DirectX float2, float3, and float4. F2, F3, and F4. These are the names. And let's create a file for these. And let's now implement them down there, and then steal the other implementations that we previously had, so that we have like one central point of managing these. OBJ file at the top. These are the ones that I want to steal. I'm going to steal them into the CPP file here, and then I'm going to start slowly moving them into their right bodies. This, and now this is called F2, F2, F3, F3. We need another F3 here, F4, 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 and F4. Okay, that's how it should be. Now, of course, we need to include it so that this is possible. Lua. I don't know. I should have called it Luma because I kind of like always saying Luma. So let's put this in here and let's put this there, and then this should work. Alright, let's see what we got. Okay, the application has finished. We are now done with it, and I have added a bit of a different message. The script is empty, basically. The script.lua now warns because I tested what I've implemented in here. And now you can see that we should use the MTL libs or cube.mtl, and every phase uses a material. The object does not use one. Red metal, green metal, blue metal, yellow, cyan, and magenta metal. And the MTL file is defining all these materials, which looks good. Let's see if it is actually good. I'm not sure if Blender can even interpret these materials. I have no plan on that, but I think with import, it should be able to import this them as well. Otherwise, we need a different viewer. But this doesn't look too bad, right? I found out how to rotate. But not. I don't. Yes, I know. Somehow it occurred to me how to move in Blender. I can't tell you why, but it occurred to me. Yeah, that's what we got. This is exactly what we want. You can see that we have these different phases. We have RGB around, and then we have the cyan, we have the yellow, and the magenta. So, well, we actually have a cube, and as you can see, it's kind of reflective. Am I able to go into like the render image or something? Is it now metallic? It kinda is metallic, but it's also looking a bit ugly. I have no plan how this Blender stuff works. Is there a way to... There was this 3D viewer. Please list me a few free 3D model viewers that can view OBJ files. Come on, give me a list. There was I'm not sure how the one is called. There was one in Windows. Windows 3D viewer. How is the 3D viewer working? Is that now no longer... Is this thing no longer a thing? Is this now in the store? Do you need to manually install these? It does. I kinda thought that this thing was inside of Windows. I'm not sure. Oh my goodness. MeshLab, Blender, Meshmizer, Windows 3D Viewer. Ah, Mixed Reality Viewer. Yeah, that was something. But it's, I think, not the one MeshLab. Maybe is MeshLab the one that I was looking for? No, I don't think so. Yeah, but I got the 3D Viewer from Microsoft. I kind of like these, actually, because it did quite a well job, actually. Let's open it. I think I should still have the path in here. Ah, yeah, you can see, you can kind of like see it. You can see it's a bit better than in Blender because you can see how shiny it is. It does have a bit of an issues because it's quite shiny. You can see if I take a look at this, you can see sometimes it's kind of like blending the source. Oh. Kind of like the white, the red is, the light has a certain color associated to it. You can see I can do a bit more play around. You can actually see, yeah, you can actually see my ambient map being kind of like reflected here. Isn't there a way to load a... I can turn it around, right? This is like one of these. This is like a fancy application. I like it because you can do stuff like that. But I do kind of like have a problem that it can't. Okay, I think. Oh, I have not the Substance stuff installed on my PC. You can see it kind of looks dull in Blender because in Blender we need to set up everything on our own with the light and stuff. And this is like the 3D viewer, which I should now be able to quickly see. Kind of like the open doesn't work. The open recent. Somehow. Yeah, but now I'm a bit more in a normal one. Jump and turn. Yeah, this is like a nice animation where you can see what we have got. We got a fancy cube. It's doing what it should do. And this is why OBJ is so powerful, because with just a simple lines of text, you can already define yourself some nice stuff. And yeah, let's go. Blender is fine, but for such a thing that we want to do, it's nice. Yeah, it's really nice. I see it really getting forward. Now we could play a bit around with textures. Maybe we can. Do I have any textures laying around? I don't think so. Because do I have my Texturen? Eigene Illuminati-Auge. I think this is something that I once... This was coming from one of the tutorial series. It was kind of tempting for me to put it on, but I think our texture coordinates are not right. So, yeah, we don't have any insights on these. Ouch. You can't open this. FunView can't open this. It's a DDS texture. But actually, I think Visual Studio can open it if I double click it. Yeah, you can see the DirectX textures can be opened by Visual Studio, which is kind of funny because Visual Studio is nothing but an image program, but now it can do it. But yeah, that's it for today. I think we did quite a lot of work today. We of course want to unify this a bit. I do want to have later on a OBJ export that is automatically kind of like setting up the MTL file, the file names, and kind of like doing everything that we are now manually doing in main, because it was kind of cumbersome to write this code. We need a dedicated class that does that, because it's way too complicated for us to have like like 9 lines of code. It's way too complicated. Nobody can ever write these, so we need these. Okay, 2 lines get away because these are actually like the... I do wanna... come on. I wanna have this stuff and this stuff encapsulated. And then I wanna have a class where I can just say like append object, append material. But I don't want to make too much in this video today. And this goes also more a bit into yeah, kind of like getting this away from C++ towards the Lua interface. Because now we have kind of like a very good state of our exporting framework. So then, thank you for watching. See you in the next video. Make sure to like and subscribe. And have a nice day. Bye.